Hi everyone, and welcome to today's session. Today we'll take a look at a practical example of how you can use Amazon Q Developer operational investigations with AWS CloudWatch to troubleshoot, identify, and investigate access problems within your AWS environment. Let's get started. So to set the context, we have a simple serverless architecture. Our clients interact with an API gateway. The API gateway, as a result, will invoke a Lambda function. And this Lambda function's primary purpose is to access and recall an S3 bucket which stores random images. And these random images are then returned to the user. Now, up until recently, everything has been working perfectly and our customers have been happy. But suddenly they've reported that the application is no longer working. They report that they receive an internal server error. Now, this error at face value is very ambiguous, and as a result it can be hard to troubleshoot, pinpoint where exactly the exception is being thrown from, and it can prolong the investigation process, leading to extended periods of downtime. And this is exactly where Amazon Q Developer can come in to help. Now in this account I have a CloudWatch alarm, and this CloudWatch alarm's primary function is to monitor the 500 error metrics on my API gateway. When the alarm flips to the alarm state, I can create an action to automatically create an investigation on my behalf, and this allows me to be proactive with these issues in order to reduce the mean time to resolution. I can also start investigation from an alarm directly by clicking on the red section of this timeline, navigating to investigate, and clicking Start New Investigation. Here I can provide it with a title, and I can also provide some additional notes to set the context. Once complete, I simply start an investigation. But for the purpose of this demo, I've already started an investigation. This is the investigation that I carried out. Here we can see an observation was added once I started the investigation from the original alarm. We can see at the top that we're provided with suggestions. And these are all the suggestions that Amazon Q was able to derive from the application stack. This includes various metrics, traces, logs, CloudTrail events, all of which is very important data when trying to navigate and root cause an issue. I can choose to accept or discard a particular observation. I can also show more related to a particular service. Here I'm also able to see the Amazon Q logs, which provides all of the details on the steps carried out by Amazon Q. So let's navigate to the actual investigation itself. These are the suggestions that I added to the feed. Here we can see that I was able to add a suggestion where I was able to notice 500 errors increasing just before the start time of this event. Amazon Q was also able to pick up an elevated fault rate in my X-ray metrics associated with my API gateway. It was also able to perform a logs insights query on my API gateway logs. Again, it's providing me with the internal server error that our customers see. It's seen that this is anomalous and isn't actually available in full in the logs. It's also performed a logs insights query on my Lambda function. It found an anomalous entry where it shows me the exception thrown whenever the Lambda function tried to list the objects in the S3 bucket. It states that there is an explicit deny in the resource-based policy, so already we're off to a very good start. Amazon Q Developer was also able to see that various CloudTrail events were logged. Here it is noticed that a delete bucket policy API call was made, and a subsequent put bucket policy was made. This coincides with the time frame of when the issue started. And from here we're also provided with a deep link which takes us directly to the CloudTrail console. Here we're able to view the event record in detail. We can see the time the call was made, who made the call, and what the request parameters were. Here we can see that a bucket policy was actually introduced to our bucket. It's introducing a deny effect on the list call from the AWS principal IAM execution role for my Lambda function. So already we notice that this would be a result of why we're seeing an internal server error. So let's navigate to the AWS S3 bucket. Okay, we can see the bucket policy. So let's delete this. Everything should all be well and good now. Let's navigate back to our API gateway URL and test the application. As we can see, our application is working successfully, and our customers are now receiving the random images. This demonstrates a simple but effective way to use Amazon Q operational investigations for troubleshooting issues in your AWS environment. Thanks for watching. Don't forget to like and subscribe for more similar AWS tutorials, and please feel free to ask questions in the comments below.